In this video, we will talk about confidence intervals for means and the t-table. So the first thing to kind of remember about confidence intervals when we did it for the proportion, and let me remind you a little bit of the proportion. So when we're talking about proportion, we said that we did not know the true population parameter p. So this was unknown to us. So what we would do is that we would kind of estimate this using a point estimate p hat. Okay, and the way that we found our confidence interval, and I'm going to write CI for confidence interval, was that we had this formula, p hat plus or minus z star square root of p hat 1 minus p hat divided by n. Okay, so this is kind of like a little recap of what the confidence interval formula was. And basically what this whole formula did was that it gave me an interval of numbers where, so maybe it could have been like 0.02 and 0.04. So it basically told me that we are this some amount of confidence level, so maybe like 95% confident that the true value of this thing that is unknown lies between these two numbers. That's basically what it was with confidence intervals. So what we're going to do now is we're going to do it now for means. Okay, we're going to do the same thing, but now we're going to do it for means. In this case, our unknown parameter, and in general, we do not know what the population mean is, mu. So far we've been talking, oh, this is what mu is, but we really don't know anything about the true population mean. So what we can do is we can estimate this, and the best estimate for this is x bar. Okay, the sample mean. So this was the population mean, and this is the sample mean. Okay, so what would our confidence interval look like? Well, one thing that we can assume is by the central limit theorem, we have a normal distribution, and we know that x bar, as long as n is sufficiently large, will follow a normal distribution with a mean of mu and a standard deviation of sigma over square root of n. Okay, so if this is the distribution right here, then what I'm going to do is I'm going to, let's say mu is right here. Okay, there's the true value. And because I know that this is the distribution of x bar, well, what I'm going to do is I'm going to take one standard deviation over. So I'm going to subtract by sigma. And I'm also going to add a sigma. Okay, maybe I should write it as standard deviation. I'm going to subtract the standard deviation and add a standard deviation. And this is going to give me a certain percentage of confidence. Okay. So basically what we're doing, notice that we don't know quite what mu is. I don't know what that is. So we're going to estimate it with x bar. Okay. We're going to subtract it by a standard deviation. The standard deviation in this case is going to be sigma over square root of n. And what we're going to do is we're going to tell it, well, how far do you want this interval to be? Do you want it to be this far? Or do you want it to be this far? So we're going to write a constant z-score. So it's kind of very similar to this guy right here that we have. So we have our estimate, our z-score, and our standard deviation. Same thing here, our estimate, our z-score, and our standard deviation. Now all we just need is a plus or minus, because it can be a plus or it can be a minus. So basically, if you look at this, x bar plus or minus z star sigma over square root of n is a confidence interval. But we have a problem. The problem here is, if I don't know what the population mean is, do I know what the population standard deviation is? Do I know what the heck this guy is? No. This, I don't know what this is. If I don't know what the population mean is, you think I'm going to know what the population standard deviation is? No. And in many books, this formula is used, but this formula in this class is useless. Okay? It's not useful for us, and it's not useful at all in real life because we don't know what this guy is. But what we can do is we can try to estimate this guy. This sigma right here, let's estimate it. Just like we estimated x bar with, or estimated mu with x bar, we can estimate this sigma. Okay, how are we going to estimate it? Well, this is what we're going to do. We're going to write the formula again. So this is a useless formula that cannot be we cannot find the confidence interval of because we don't know what the population standard deviation is, we're going to change it up. What we're going to do, we're going to estimate it. So it's still going to be x bar plus or minus. Instead of, we'll talk about z in a little bit. We're going to estimate the sigma. The best way to estimate sigma is with the sample standard deviation, s sub x. So this will be s sub x over square root of n. The thing is, when you estimate s of x, you change the distribution, okay? So this is no longer going to be z. This is now going to be t, okay? So now z here was a normal curve. Now it's not going to be a normal curve anymore. Now it's going to be a t distribution. So my confidence interval is going to be this formula, okay? And actually, I'm going to write an n minus 1 on the bottom. Now, what exactly is this? So what is this t, okay? So let's talk about the t distribution or the student t distribution. Okay, so the student t distribution, basically what it is, it looks like this. Okay, this is what the student t distribution looks like. And actually, you might think about, wait a minute, this looks just like a normal curve. Well, there are some differences, okay? Here are some differences. So this is a t distribution. Looks a lot like a normal curve. But the only thing is the following thing. The student t distribution has fatter tails. So you can see that here at the tails, these are a little bit fatter, okay? So they're a little thicker, okay? So it has fatter tails, okay? That's one thing. Another thing is that as n increases, the t distribution starts to look like a normal z distribution, so a standard normal. So basically, as n gets bigger and bigger and bigger, it starts becoming like the z value, okay? So you can kind of think of this t distribution as kind of like as a normal curve that ate a lot, and then as it n increases, it starts getting thinner and thinner. I don't know. Okay, another feature about it is that it has something called degrees of freedom. And we usually denote this degrees of freedom with df. And the degrees of freedom is just equal to n minus 1, and where n is a number of samples. Now, there's a lot of reasons why the degrees of freedom are n minus 1. It's a little complicated, but basically you can kind of think about it as if you have 10 variables or 10 observations and you're trying to find the mean of it, then 9 variables you are free to kind of choose whatever you want, but the last one you kind of already decided what that is, because if you have 5 numbers, okay, like 5 plus 2 plus 3 plus 4 plus x, right? If you have 5 numbers, and if I decided these numbers, I can choose whatever I want, right? I can choose whatever number I want, okay? But however, if I want this to be equal to 50, well, x is already decided because it's going to be really easy to figure out what x is given these numbers. But these numbers, I can change into whatever I want, but this last number is always going to be decided because we already know the other ones. So then you have n minus 1 degrees of freedom. Honestly, if you didn't understand that, it's okay. You just need to be able to kind of be able to do this problem. So so this is basically what it is. It has fatter tails. As n increases, the t distribution starts to look a lot like a normal z. So degrees of freedom is also df is equal to n minus 1. Okay, so basically what this means is that the student t distribution is good because it's good for small samples. So good for small samples. So if you are only sampling, for small samples. So if you're only sampling a couple of people, you can use a student t distribution. It will be a better estimate than than usually the regular z. So before we start doing the student-teacher distribution, let me show you what exactly this looks like. So we don't have normal CDF. If you have a graphing calculator, you can find probabilities and you can do all these different things, but you don't have that. Instead, what we're going to do is something called the T-table. So if you log into Canvas under the resources, you'll be able to see this table, okay? So basically, if you look at this table, you have a couple of things here. All the way down, it gives you the confidence levels, okay? So it tells you a 95% confidence, 98% confidence, 99% confidence, all these different confidence levels, okay? At the left-hand side, you'll see the degrees of freedom, DF. So these are the degrees of freedom. And in the inside, it tells you what the value of T star is going to be, okay? So this is what we're going to be using. And on an exam, I will give you this T-table. Okay, so let me give you a couple of examples of how to use a T-table. So basically, these are kind of the directions. How to use or how to find T star. And the reason why we want to find T star is because when we're finding a confidence interval, we're going to know what the mean is. We're going to know the sample standard deviation. We're going to know the n value of n. We just need to figure out what T star is. So remember, X bar is sample mean. S sub x is sample standard deviation. N is number of samples. Okay, and then T star is just basically going to be the, we can call it the critical value. We can call it that. Just call it critical value for now, for T. Okay, so how are we going to find this value of T star? So it's actually really easy. The first thing that you want to do is find degrees of freedom. Remember, degrees of freedom is n minus 1. So you're going to take n and subtract it from 1. Locate, df with desired confidence level. And match to find T star n minus 1. And I'll put a little note. If DF is not there, estimate it with the closest value. Okay, and I'll explain what that means. Okay, so so this is basically the directions on how to find T star. So let's do a couple of examples. So to kind of give us a little gist of what that looks like. The problem, go ahead and write this down if you'd like. So we want to find T star n minus 1. So part A says we want to find T star n minus 1 with a 95% confidence and n equals 13. Okay, so the first thing that we're going to do, so if we look at our directions, the first thing that we want to do is find the degrees of freedom. So degrees of freedom is going to be n minus 1. And in this case, it's equal to 13 minus 1, which is going to give me 12. Okay, so that's my degrees of freedom. The next step is locate the degrees of freedom with the desired confidence and match to find T star n minus 1. So we want 95% confidence and degrees of freedom of 12. So we're going to go to my T-table. Okay, here is 95% confidence. 95% is all of this. Whoops. So here's my 95%. So this is all of my column. And I'm going to match it with my degrees of freedom. Remember, degrees of freedom is right here. And the degrees of freedom, if we look back, it's going to be 12. So we're going to look at 12. 12 is right here. So what we're going to do is we're going to match this 12 with the degrees of freedom. Okay, so here was 95, 12. So we're going to, the confidence level is all on the bottom. Degrees of freedom is on the left-hand side. And the number that matches up is 2.179. So that's T star n minus 1, 2.179. So T star n minus 1 is, well, you can write it like this, because remember, n minus 1 is just 12. It's just 2. Oh, what was it? 2.179. And that's it. That's just the answer. Okay? All right, so now let's do part B. We want to find a 99% confidence with n equals 30. Let's first start off with the degrees of freedom. That's n minus 1. So that's going to be 30 minus 1, which gives me 29. So we're going to match 29 with a 99% confidence. Okay. So first, let's look at 99% confidence. 99% confidence is right here. So I'm going to do this. Whoa, why does it keep going that way? So here's 99% confidence. All of this guy is 99% confidence. And my degrees of freedom in this case was 29. So I'm going to locate 29, which is going to be right here. And if you see, the number that matches up with the 99% confidence is this 2.756. Okay, so 2.756 is my answer. So you can write T star if you want to. You can put T star 29 if you want. Okay, I will accept both. Okay, let's do part C. Part C, you want an 80% confidence with n equals 43. So now, my degrees of freedom is going to be 43 minus 1, gives me 42. And you want it at an 80% confidence. Okay, so 80% confidence is right here. Here's 80%. All of these guys are 80% confidence. And we want to do it at 40, what was it, 42. Now notice 42 is not on the T-table, okay? So you have to look at the closest one. The closest one is 40, okay? So 40 will be my closest one. So I'm going to use the one for 40. So we're going to use this one, 1.303. So T star 42. Wait, what was it? 1.303. Okay, so that's my T star. Okay, now let's look at the last problem. So we want to look for 98% confidence with n equals 51. So my degrees of freedom will be 51 minus 1, which gives me 50. So at a 98% confidence, okay, so we're going to look for 98 and look for 50. So 98, give me yellow. 98 is right here. And we're going to, so this is all of 98. And we're going to look for 50. 50, notice that it's not here. Okay, so let me erase a couple of these things. It's getting kind of messy. So notice that 50 is not located. It's going to be between 40 and 60, right in the middle. Okay, so you can do one of two things. You can either choose one of them, or what I think would be a better estimate is to kind of take a sum of that. Okay, so it will kind of give you an idea of where exactly the value is going to be. So let's write these two things down. We're just going to take the average of these two. So we're just going to take the average. So T star of 50, we're just going to average them. So it was 2.423 and 2.39. We're just going to add them and divide it by 2. So just take the mean of these. So when you add them and divide it by 2, you're going to get 2.4065. So you can kind of estimate it this way. Okay. And actually, I feel like this would be a little bit better than just picking one of them, because you will be overestimating or underestimating. So you'll be somewhere in the middle. Okay. So nothing too bad to find the T stars. Really, really basic. Just be careful with your degrees of freedom.